This conference will now be recorded.
Fine, guys. We'll get started today with the first topic, uh, more into the concepts about the JVM and few basics of Java. Before we go into the engineering topics, uh, m- many of you might know about this. A few of you might not very much aware of this. So we just wanted to set some concepts, basics, so that during engineering, when you're going to talk about problem with the method or object or the code, you would be able to relate it a little easily. I was saying about uh, whenever we are going to talk to the developer, it is always going to be a tough time, right? Sharing the testing results, finding out the problem. Now, with finding out problem in their code, they're always going to come back saying with some kind of a response saying it is not the problem with the code or with their application. So if we are confident, they will mostly accept the defect and they will take it forward. So it's more about how confidently we can go and talk to them. Okay. So what we'll do, I'll do is I'll probably today we'll go over with the concepts about JVM and Java. And if you guys are interested, uh, depending upon whoever is interested in one of the weekend, Saturday or Sunday, we can spend more time on some of the programs, Java programs, and so on, so that you can even more get um, comfortable with how the programs are going to work. Not as an application developer, we are not going to become a developer. For us to uh, get more and more confident, if you can just get hands-on in any other programming language, it will boost up your confidence, right? So any other weekend, depending upon your availability next in the February month, we can have that session where I can go over and then spend more time on specific to Java. Okay, fine. Um Most of you might have heard about JDK, JVM, JRE, right? So whenever you're going to install Java, so that is a Java, installing Java is going to be the prerequisite for you to have any hands-on in your laptop. Okay, you might have already have this in your laptop. You might not even know about it. Okay, even in your organization, in your load generators, in your other VMs, you will still definitely have um, Java. The main reason is most of the tools will require Java. Even Jmeter will require Java. Uh, Eclipse will require Java. Tomcat will require Java. Most of the uh, softwares will require Java to be there in the machine. So even without your knowledge, Java might be there. But in your laptop, okay, you can just go to command prompt, okay, and then type in whether the Java is installed or not. You can just check for the version of Java as well. Okay, so it will say the Java version is 1.8 or 1.11, whatever it is, whatever Java version you're having it will show it here. Just make sure that Java is installed in your machine. So this is one way you can check your availability of Java as well as your Java version. Okay, second is if it is not there, okay, then you need to install the Java from the Oracle site. I have given the URL from where it can be downloaded in the Google Sheet. Okay, or you can just go Google, download Java. It will get downloaded. Okay, second thing what you have to do is you need to go and set some environmental variables. Before that, I'll tell you what is the difference between JDK, JVM, and JRE. Okay, it's a very simple. When if at all you guys have used load runner, right? Load runner for your performance testing. If at all you have used it, there are different components in load runner, right? You have controller, you have Vugen, you have load generators. Okay. For in a single machine, you can have everything. If you want to do execution, if you want to do scripting, if you want to do analysis, you will have all the components in a machine. But if you wanted to run only the load generation, in that machine, you don't need a controller, or you don't need analysis, or you don't need the scripting Vusion, right? Similarly, uh, JRE, your Java runtime environment, okay, which will have your JVM inside that. Okay, JRE is the one which is required for execution. Okay, it is not required for development of your application or a code, which means a developer machine will need everything. They need a JDK, Java Development Kit. JDK is the superset which will comprise of JRE plus your compilers, debuggers, everything. For a developer to do development, it needs JDK. Okay, for um, the people who are going to just use it for execution, for example, you might have performance environment where you will have Tomcat, where you will just deploy the application, right? In that, you don't need an entire JDK. You will find the JRE alone. That's a difference uh, between JDK and JRE. And inside JRE, you will have JVM, which is the Java Virtual Machine. This JVM is a whole thing that we are going to learn inside the JVM. What is the JVM architecture? How is the memory is organized? What are the various components of memory? Because the JVM is what it is going to run your application. It is what the memory is going to get allocated. Processing is going to happen. All the heap issues, thread issues, everything is going to happen within JVM. Okay, it's a virtual machine. It's like your OS, but there is going to be a one virtual machine allocated for your application whenever you're going to start your application. Okay, so we will look into it in detail about JVM, but the difference between JDK and JR is as simple as that. Okay, since you are going to do a lot of debugging, you're going to use profiling tools, right? You go and install Java, the entire JDK. Okay, if at all there is an option while installing, if it is going to ask you whether you need a JDK or a JRE, you just go and install the entire JDK. Once you install the JDK or Java, okay, you open up these environmental variables. Just type in, you can go to the control panel also, and then environmental variables. Okay, you need to tell your laptop where the Java is installed. Okay, so that whenever, say for example, I went to the command prompt, I typed in Java-version. So this command prompt should know if at all Java is installed, where is installed. So it will go and check your system variables, the environmental variables. Here you need to create a variable called Java, and then provide your JDK path. Okay, so for the first time, you need to go to the new, type in Java, and then type in the path. Okay, so Java, you need to set it. Maybe whenever you're going to do it, refer to this video, or even if you go to Google, you will find a lot of information about this. But make sure that the Java will have /bin. Okay, a /bin, and there's no other slash after that. And for Java home, it is till JDK alone. It won't include bin directory. Okay, these things will make a difference. If at all we by mistake, if we add a backslash or we miss a backslash, then it won't uh, recognize your Java properly, and you will get a lot of other problems. So Java is a one, Java home is a one, and then there is something, there will be another variable called path variable. Already it will be there. The path variable, if you see, there are, for all other softwares, you might have lot more entries. For your Java also, just go and include your the bin directory, similar to whatever you've given it in the Java, right? Same thing you have it here as well. Java JDK / bin. Okay, so three things. One is Java, one is Java home, and then in the path variable, just go and provide the JDK /bin without the backslash at the end as a one of the path entry. Just give 3. Okay, so once you do all these 3 things, then you can just say okay, and then go back to your close your command prompt, the old command prompt, and then open it, new command prompt. Okay, the one more mistake is when you first try it, if it is going to say Java is not installed, and then when you go and make that correction in the environmental variables, come back to the same command prompt, it won't recognize. Okay, you just need to that's the common problem what we do it, and then we'll keep troubleshooting why it is not showing. You always open a new command prompt and then try it out, it will work. Okay, Java version, you will get the Java version. Okay, so yeah, so these are the things you need to do it as part of your initial setup before even you prepare to install any other JProfilers or Eclipse or Tomcat. Okay, download the Java, install the Java, and then set the environmental variables. Make sure that Java version is going to provide you the version that you have installed. Yeah, it's very simple, 5 minutes work. But sometimes if it is not installed properly, or if you're not setting up the variable properly, we have seen some kind of a weird problem will keep happening. So just try it out yourself. It's going to be very straightforward only. Okay. Okay. Fine. Before going to the JVM, right? I want to spend good amount of time in JVM for sure today. Before that, some basics about Java itself, right? Because we're going to see a lot of these things about class, object, method, package, primitive, non-primitive data types. So it should not be a black box whenever you're going to go and tell your developer that there is a problem in your method, or your object is having a memory leak, or your this class file is what you are having a problem, right? So again, it's very basics of Java, but this is very good enough for us to get that thing going when you're going to do this engineering analysis. Okay, any Java program. Okay, let's not complicate it. Somebody you in this group will might have already know Java. For you guys, it might be very basics. For people who doesn't know Java, right, this is going to be really helpful in getting that very small basics for you to get that engineering sessions more interested. Okay, so any programs, any Java program, any big application you take it, right, if you break down it, you will have the skeleton. There will be definitely, see, the hierarchy is there is going to be a packages. Say Amazon, if you take Amazon as an example, Amazon e-commerce website. Okay, it is a web application, right? It will have a package, Amazon package. Inside that there will be thousands, hundreds of program, or whatever, 10, 20, 30 programs. Every program is nothing but a class file. So a package will have multiple class file. A class file is nothing but a Java program. Okay, and then every program or every class file, inside that it's going to have multiple methods. Okay, say for example, you would have learned this in your college, or even the schools, right? Every program is going to have 2 things. It has to store the input. For that we will declare variables, and then output will also get stored in the variable, and in between there is going to be a processing. Say you're going to add 2 numbers, you're going to subtract 2 numbers, you're going to connect to a database, you're going to process some data, whatever that is. So those processing, all your sum, addition, subtraction, that is going to be a method. Okay, so a class file will have some kind of a variable declaration, and then it will have a method. Inside that you will have addition and subtraction. Okay, and when we talk about the variables, Java has divided that into 2 types, primitive and non-primitive. Okay, don't try to probably remember this too much, not required. The main connection between primitive and non-primitive is when we are going to talk about Java memory, when you're going to learn about the stack and heap, this will be explained more, because the Java has done this segregation in such a way that all the primitive data will get stored in the stack memory. All non-primitive will get stored in the your heap memory. Okay, that is why there is a difference between non-primitive and primitive. And small differences. All your primitive will start with small letter. Your integer, byte, character, all will hold very small size of memory only. But non-primitive, it is strings, arrays, and all. Um, it will hold more memory, and that is why it will go to heap. Don't worry about it. For now, there are only two data types: primitive and non-primitive. All required to store data. That's it. Any program will have something to store data, and then method to process it. That's a template of any Java. Now in between there are something called object. Okay, um, I'll give an example to explain this object. You might have heard about this to so many places, so many people try to explain what is object. Okay, I'll try to probably keep it very simple. It might not be 100% accurate in terms of explaining the object, but it is. I just want to make sure that you understand it better so that you won't forget it. Okay, I'll take our real-time example of again our Amazon.com. Okay, so you connect to Amazon.com. I also connect to Amazon.com. Okay, and you are going to go and order a laptop. Okay, you'll choose a quantity of one and probably select a Lenovo. I will go and select probably a mobile. I need two mobile for Samsung. Okay, and you will go and check the price for that particular Lenovo laptop, and I will go and check the price for my two Samsung mobile. Okay, in the application code. Okay, whenever you're going to click submit, when I'm going to click a submit, in the application server, there is going to be only one program or a class file for calculating the price. There's a price calculator class file will be there. There's only one class file, but the requests are coming from you, me, similarly, n number of people will um, do this price calculation depending upon whatever they do a selection, right? So what happens? There is only one class file, but the request from you are having a laptop and quantity one. I'm having a mobile and quantity two. What happens is at runtime, whenever that class file is going to get called for calculation, your JVM will create a duplicate of that class file, for one duplicate for you, one duplicate for me, and it will store that duplicate of that thing called object in the heap. Okay, so which means one class file will have 50 hundreds of duplicate instance called objects, depending upon how many people are going to call that program at the runtime. And for a duplicate one, inside that program you would have declared a string of product, quantity of integer, right? So for you it will take the input as one as a quantity, and then string as the laptop. For me it will be quantity as two, and then string as mobile. And then it will go to the method, it will do the execution, it will find out the product price is 1000 USD for me or 2000 USD for you, and it will respond back to the you and me saying this is the quantity, this is the product you ordered, and this is the price, and for me this is the price, right? That's how it is going to work end to end. So there will be a physically there will be one class file, and at the runtime, whenever a class file is going to get called, it is going to create a duplicate of that class file, which is called as an object. Okay, so that's how that is what object is. Nothing nothing more complicated than that. Okay, another example I have given in this slide is more, for example, in a college, if there are example, there's a registration application, and there is going to be a registration class class file, which is going to accept name, your age, color, all these whatever you are good in the skills you might be playing. You might be a cricket player, or you might be a dancer, you might be a singer, right? So what will happen is, when a person is going to get registered, registration class file will be called. Now a duplicate of registration class file will be loaded. It will take a name as Shankar, a male, and then he's a dancer, same way another person with XYZ. All these things will get stored in the your database, but there's only one class file called student class file. And at the runtime, 1 2 3 4 5 different objects are going to get created, which is a duplicate of the student class file, which will hold the data as per the input that you provide. Okay. I'll just show you a Eclipse. Let me go and open the Eclipse and show you for the e-library application as well, right? Any big application you take it, it might have 3 4 packages. It will have hundreds of class files, but if you break it down, everything is going to be end of the day packages, class files, methods, objects. Just give me 1 minute. I'll open the Eclipse. Okay, let it open. Probably it will take a couple of seconds for the Eclipse to come up. Meanwhile, let me go to the slide. Okay, I'll show you this. Yeah, anyway, the few sample programs. So this is what I probably over the weekend, right? Maybe in February, some of the weekend, we can agree, so that I can spend more time on creating some. I used to have this. Yeah, will Java programs, let's code kind of a session where we'll go and create a Java project. We'll go and create a simple class file. Even whoever doesn't have any knowledge, the idea is to do a template based coding, because we are not going to be a developer, which is more about we getting comfortable with the programs. So we'll go and create multiple class files, calling one method from another method, and then creating a DB connections, adding the external jar files. All these things we will try to do ourselves, so that it will be easy for us to um, see whenever we are going to find problems, right? It is always going to be like hierarchical root cause. Class A will call class B. From class B, it will call a method C from another class file. Your application is going to have multiple class file, and from each class file, it might call the other class file to do some other operation, right? All these things, if you are going to do it practically by yourself, it will be more and more easy and confident. And all these things are all very simple things. Don't worry, even you don't know Java. It's all template based program is what we are trying to learn for our engineering perspective. Okay, so we'll do this probably sometime in the weekend. Just give me one couple of seconds. I'll just take some water. So while it comes up, right, I was talking about this primitive and non-primitive, correct? So if you look into the overall your JVM architecture, okay, so JVM architecture, again, this is not going to be really useful for a practical perspective, but whenever you're going to go for an interview, there's going to be definite chance that they might ask you questions on these components. So it is good to know what is what. Uh, uh, Not required to go get into more details about it, because it's not going to be used practically. Apart from a few components, the rest of the components we don't need to dig into it very in depth. Okay, so in the right hand side, if you see, right, I have given the flow of your JVM. So .java is your program. We are going to create a class file, right? We are going to go and write a program with this variable declaration and then method execution. A simple program, you will save it, which will save as a .java. When you compile that Java program, it will become a .class. Okay, which they call it as a when you compile your Java program, it will be a bytecode. Format of your compiled program is a bytecode. I don't need to worry about what is bytecode, what is inside that. It's just all zeros and ones you can assume. Okay, and that is what it will, when you're going to run the program, when you're going to execute this program, it will get loaded. A JVM will be created, and then that JVM is what it is going to accept your um, all your programs. Okay, so the entire class files will get loaded into the JVM. So that's the first thing. When you're going to run a program, either you're going to run a program from Eclipse or you're going to run your application from your Tomcat, a JVM will get started and all the class file will get loaded. That is the first thing called class loader. Okay, for example, if I go to this Eclipse, I take any program. Okay, let me open a simple program. So if you see the hierarchy, right, my Java is a project. Inside that you will have a package, and inside the package you might have different programs. Similarly, if I open this, my Java 2 is another project. Inside that you will have a package, and inside the package you will have multiple Java programs. .java. .java is your program that you write. Okay, I was talking about this price calculation, right? So in the price calculation, you have your method, which is going to do a price calculation. Any Java program is going to have a method, and you're going to declare some of the variables: int, string, boolean, character, and inside, and then you're going to do some processing, right? Price value is equal to cost into quantity. Those kind of everything is going to be inside the method. So which means if you take a simple program or if you take a big application like a e-library, right? If you take a e-library, if you go inside the source, there are multiple packages, and inside a package you will have multiple Java files. Adding a book, doing a admin login, doing a logout, issuing a book, editing the librarian, deleting it, all the functionalities, it will be an individual um, Java file, right? And inside the Java file, you're going to have a method. See, that's how. And inside the method, you're going to have the business logic, the actual processing, right? See, if you take any complex application or any simple application, the hierarchy is going to be: you're going to have a package, you're going to have a multiple Java file, which is nothing but a class file. If you expand it, for every .java, there will be a class file. If you compile it, there will be a class file that will be created for each of this Java. Okay, so this is, see, this hierarchy, and from admin login you might call other class files that we will I'll explain you when we're going to go into the engineering sessions. This is going to be very important, because when we say about root cause, right, what is the root cause of login having a high response time, then what will happen is a control will come to admin login. From admin login, not everything will happen within admin login. Say for example, for login, right, you might have to go and call the single sign-on validation. For single sign-on, there might be another class file. Okay, and single sign-on, for inside the single sign-on, it might have probably an LDAP validation. So it will call LDAP class file. So from admin login, it will call the single sign-on class file. From single sign-on class file, it will call the LDAP class file. Okay, so and the problem might be there in the LDAP method. So when you going to analyze this response time in JA Profiler, it will show the hierarchy as the call came to admin login. From admin login, the call went to a single sign-on Java. From single sign-on Java, it went to LDAP. and that is where the response time is high. Okay, so for that is where it is very important to understand. Okay, any application program will have multiple packages. Each package will have multiple class files, and from one class file other class file will be called. This kind of a flow is going to be important when we are going to do a profiling. That is a root cause we are going to identify, and in the root cause you will get this structure of hierarchy. Okay, so I'll explain it more and more when we're going to talk about that in the engineering session. But yeah, for this purpose is what I'm asking you to just get some basics about Java, install Eclipse, and in one of the weekend session we'll definitely we'll try. This is not a mandatory, but it is good to have hands on few small Java programs. See, whatever program I was talking about, price calculation, right? It's very simple calculation program only. So these things are probably good to have. If you are interested, we can have some maybe next week or next to next week. On Saturday, we'll have some hands-on in Java programs, but it's not a mandatory to have it for our engineering sessions. So what happens? Java dot class, and when I go to execute, it will go into a JVM, and JVM will do that execution and it will provide the output. Okay, so first thing is class loader. If you look into the e-library application, right, you'll have 20-30 class files, and along with that there will also be a some other system runtime library class files, JRE system library run files. So along with your own class files, there will be some external jar files you might have added. Okay, so there's something called import. Okay, in the organization, you might write your own programs. You might also import other people programs, some reusable modules, right? Um, Logins, log out and all, it's a common single sign-on, all common class files. You might have done the import. You have to import those class files. Okay, so let me why this is important from an engineering perspective is uh, the problem might be within your class files, whatever the application team has created, and the problem could also be the with the other jar files which you might import it. Okay, so these jar files could be a third-party libraries, some of the from Maven or somewhere they might have downloaded the jar file for supporting their program, or they might have got the jar file from the other development teams within the organization. Okay, so as part of your skeleton, there's something called imports. Okay, imports is nothing but whenever you wanted to use the other people's program, you have to import their package into your application project, and that it will get added here. So what will happen is when you're going to start this execution, or Tomcat is going to start your application, all the class file, your own class file, all the other external class file will get loaded into the JVM. Okay, again, don't if you don't understand completely, don't worry. As we move along, these things will become more relevant. This is theory absolutely, because there is no way. It's an architecture, it's a components. I'm trying to explain it in a simpler way. Even if you don't understand, don't worry. Don't think that you are you're missing out something, or you're not good enough, so that you're not understanding. Don't think about it. It's all you will understand as we move along. You will be able to correlate this very easily. Okay, and again, this class loader and all, it's not even required for us to do the engineering. This is for us to understand the JVM architecture. Okay, so class loader is going to load all the class files. That is the first thing. That's the first component of JVM architecture. Second is your JVM memory. Okay, that is where all the things are going to get stored. Inside the JVM memory, there are 5 components. Okay, you have meta space. There is nothing called method area now. It is a meta space, heap, stacks, registers, and native method stacks. Okay, out of these 5 components, um, only one component is going to be super important for us for monitoring, configuration, tuning. Problems are going to get created in the heap. We are going to analyze the heap problem, everything. So heap is the one which is going to be our area of learning, area of um, uh, uh, issues, area of tuning, everything. Okay, so we are going to look into it in detail. And there's one more thing called stack. Okay, so heap versus stack. uh, Again, stack is also not very important, because oddly it is going to have very less memory stored. The difference between heap and stack, right? I was talking about primitive and non-primitive. Okay, so in a program, whenever you're going to declare an integer, whenever you're going to declare the um, boolean, your character, all the small sized memory, I would say, all the primitive variables will get stored in the stack. Okay, and all other strings, arrays, objects that are going to get created will be stored in the heap. That is why the heap is going to have larger area. We will go and assign 4 GB of heap, 8 GB of heap, 16 GB of heap size. Okay, for stack we will not even assign it. It will be a default value that JVM will handle. Okay, majority of your storage is going to be in the heap, and that is why we go and provide the heap configuration. And your objects, array, strings, everything is going to get stored in the heap. That's a basic difference. When we talk about primitive and non-primitive, that is how it is getting aligned into stack and heap. In the program, whatever you're going to declare as a primitive, it is going to be part of stack. And sorry, the non-primitive, it is primitive is going to be part of your stack, and non-primitive is going to be part of your heap. And it is going to happen by default by JVM. Developer is not going to do anything. Performance engineer is not going to do anything. Okay, just that the JVM works in such way. And there is one more important aspect to this stack and heap when it comes to garbage collection. I will not go in detail into that. When we are going to talk about the memory, heap analysis, profiling, GC, I'll spend some more time on this stack and heap, and the relationship between stack and heap, how it is going to relate to a garbage collection also. Okay, for now, inside your JVM memory, there are 5 components. In that, heap is the one which is very, very important, where we are going to focus more and more time. And then stack is something where we'll also learn about some stack issue practically next week. But it's not going to be that important, where we are during a load testing or during our benchmarking, we'll not even spend time on the stack at all. Only on the heap we'll spend. Okay, CP is going to store the objects, array, strings. Just the JVM stack is going to store all your primitive variables. There is one more thing called native stack. There's a JVM stack and the native stack. Again, the native stack, by definition, we don't need to go and further understand a lot of things about native stack. Just one liner. From a Java program, you might call a Python program, or you might call your Windows program. So any other native program that you're going to call from a Java, that references. So from a Java, you might call a Python for some machine learning purpose, right? For whatever reason, externally, entirely from externally, you're going to call a Python program. That references will be stored in the stack. Okay, I'm line number 100. I'm going to call a Python program, and Python is going to run outside of your JVM, not inside of your JVM, right? Totally outside of your JVM. This Java will hold a reference saying, okay, I'm calling a Python program. I'll just wait for the Python to get completed. There'll be some temporary memory needed for that reference. That will get stored in your native method stack. So JVM, Java community have designed in such a way that to keep it very simple, to keep it in a logical way, that whenever I'm going to call another program, references for that will be stored in a separate place, because it is always going to be very, very small in memory, and I don't need to complicate that, confuse that with the other components. Okay. Similarly, PC register is another very, very small memory component, and it is just going to do the registry. The name register means it's going to keep hold of the registry, which means whichever lines of execution is happening, that meta information is going to get stored in the registry. Okay, I'm in the method A, line number 10, line number 11. That information, metadata of information, is going to get stored in the your register. Okay, it's very small memory, no tuning, no configuration. We will not even know what is happening inside that. We will not monitor it, just that it is classified as a different section inside memory. Nothing to for us to learn about this anything at all. Okay, there's one more thing called metaspace. Okay, metaspace is the one, as the name says, it's going to hold the metadata about all the your classes. Okay, all the classes are getting loaded, all the class names, all the external jars, all the other class file names, the metadata about all the classes will get stored in the metaspace. Okay, again, we will let Java JVM 2 assign memory to metaspace, stacks, registers, native, with all the out of 5 components, 4 components will be handled by JVM by itself. Okay, there's nothing that we will do a lot as application developer or a performance engineer. We'll worry about these things. All these things are all for your JVM to work properly. You're going to have the registers, you're going to have metaspace, you're going to have method stacks. Okay, only heap is the one where we will get involved for monitoring, for tuning, configuration, finding out problems, fixing the problems. The heap is the only one which will be under our consideration. Okay, so that heap is what we will look into it very detailed when we get into the your memory sessions. But overall, from a JVM perspective, you're going to have a JVM memory component. Inside that, you're going to have 5 components, and out of this, only one component we will go and assign memory, and remaining thing we will let JVM to assign the memory on its own, because it's all very small sized memory is what it is going to get required, and we will let the JVM to handle by on its own. So, and then comes your when we talk about JVM, right, it will do 2 things. It has to hold, it has to store runtime data. That is what JVM memory is going to do. And then it has to do the execution, right? It has to get the input, it has to do the output. That is where the execution engine is going to come into the picture. So this execution engine, there is something called, there are 4 components here. Out of these 4 components, garbage collection is one of the component. GC is one of the component. When I say GC, it is a set of predefined programs, algorithms, which is going to run throughout your, whenever you're going to start a JVM, the GC is also going to get started. And we'll learn a lot about GC later. Just a definition of what I'm saying, right? And this garbage collection is a one which is going to keep looking into the heap, and it is going to delete the heap area, because the heap, whatever you're going to configure, right, it is going to be, say, 4 GB, 8 GB, 12 GB. There's always a limit. There's nothing called unlimited. Okay, and whenever there is going to be a class file going to go called, the objects are going to get created, right? And the objects are going to be there in the heap. So throughout the day, hundreds, thousands of objects are going to get created. Some point of time, you will not have the space for the new object to get created. So somebody has to delete it. So you go and call a price calculator. You got your price. Object is created in the heap. Is that object required after a couple of seconds? No, not required. Your job is done. The duplicate object created is not required, because that is created only for you. So it has to be deleted. Similarly for me, similarly for hundreds of requests, right? That work will be done by this garbage collector. Okay, so GC component is part of the execution engine, which will make sure that it will keep looking into the objects which is not required, and then it will keep deleting it. why it is going to do it, how it is going to do it, how it will know it is not required or not. All these things we will learn when we are going to talk about the garbage collection later. From a definition perspective, within the execution engine, GC is an important component and only component which we will control it, which will be able to go and add some tuning parameters, which we will go and monitor it, analyze it, the GC alone. Other three things are all just that it is going to work on its own. Interpreter, it is just going to convert your bytecode. I told about bytecode, right? The class file, the bytecode, it is going to convert the bytecode into a mission understandable code. So you all know that Java is a OS independent software or a programming language, right? You create your jar file or a war file in your Windows machine, go and put it in the Linux box. When you're going to start that application, it will work. In the Android, it will work. In the Mac, it will work, because the Java JDK which you will install in the Linux machine will have a component called interpreter. Interpreter in Linux is going to be different. Linux in the Windows, it is going to be different. In the Mac, it is going to be different. The input is same. Input is bytecode. The interpreter in Linux will convert that bytecode into a Linux understandable code. Similarly, in Windows, it will convert the bytecode into the Windows understandable code. So interpreter's job is to convert the bytecode into native OS understandable code. That is job. I mean, just that we need to know what is interpreter. We will not, from a performance engineering point of view, interpreter or hotspot profiler or JIT compiler, we will not control anything. This JIT compiler and hotspot profiler, some way it is related to the performance, but we don't have control on it. The hotspot profiler, as a name mentioned, hotspot, right? It will keep looking into the all the code execution, and then whichever method it's taking more time, spend execution time, okay, it will ask the JIT compiler to pre-compile it. When I say pre-compile it, what happens is at the runtime only, the interpreter will convert that bytecode to bytecode into the native understandable code, right? With JIT compiler, it will pre-compile that. When whichever method is taking more time, it will pre-compile it, and then it will store the compiled code permanently in the your JVM memory, so that it will try to speed up that method execution. For that purpose, hotspot profiler will keep looking into the methods which are taking more time, considerable time, and then it will try to reduce that interpretation time. That is the work of both hotspot profiler and JIT compiler. That's again just a definition. We will not do anything more than that with hotspot profiler or JIT compiler or interpreter. In the execution engine, GC is the only component which we will learn more and more. Try to learn how to analyze it, how to configure the GC logs, how to monitor the GC logs, and tune some of the important parameters. Okay, I'll take a pause here. Every day, last 10 minutes, we'll spend time on question and answers. So today, what we have learned is more about the basics about Java program, basics about your JVM architecture, so that when we move into the engineering session, you will be able to correlate few things what we have learned. So I'll take a pause here. If you have any question, guys, put it in the chat or unmute, and you can ask the question also. Yeah, feel free to put it in the chat, or you can unmute and ask the questions. The access to the drive and sheet, I'll give it by today for sure to everybody who have registered. So that you will get access to the sheet where you can also ask questions. If you couldn't able to ask the question in the class, you can also go and add those questions in the Excel sheet. So for sure will provide the access by today. Can we have multiple JVMs for single application to improve the application performance? Yes, that is how it works, right? When we are going to learn about JVM benchmarking, your expectation would be to load 1,000 users. Okay, and when we do this JVM benchmarking, we will end up saying, okay, from single JVM with 4 GB heap with 100 threads, it can handle 300 users. Okay, that is optimal. If you're going to try to increase it further, your response time will get impacted, right, or your CPU will increase. So then what we will do is, there are a couple of things we can go and add 4 VMs, and in each VM you will have 1 JVM, so that the load will be 250 per JVM. Okay, so that so to answer your question, yes, definitely that is how we do it. Multiple JVMs will be added to handle your load. That is why we do JVM benchmarking. So as I mentioned other day, right, we will learn about, we'll first go and do the response time optimization, and then we will go and do the memory leak analysis, optimize the memory, and then learn about thread configuration, and then we will go and learn the JVM benchmarking. During JVM benchmarking, we will learn about, okay, 1 JVM can handle these many users with 4 GB heap with 100 threads. Then for my requirement is 10,000 users as a load. Then I need to go and have 10 such JVMs or 10 such VM to handle 10,000 users. So definitely multiple JVM will be used to handle the single application, for sure. Even if a single JVM can handle the load, for more from an availability perspective, something goes happen to the machine, right? It's always good to have at least 2 VMs, so that even one VM goes down for any reason, load will be sent to the other VMs. So for performance and for availability purpose, definitely we will have multiple JVMs. Different GC algorithm required to learn in engineering purposes. Okay, so different GC algorithms, we will try to understand what are the different algorithms and what is the applicability of that. See, few of the batch Java programs might need a different algorithms, but for all online applications, for all web application, we are not going to keep changing the algorithms. No, there is always going to be only one algorithm which we are going to use it for online application, web application. Okay, in that we might use different tuning parameters here and there, tuning flags to improve the performance. Otherwise, for web applications, it is always going to be only one algorithm. If it is a batch application, then we can actually do a exercise to see which algorithm might be different, will be providing a better performance for batch. But otherwise, it is not required. How can we come to a conclusion that 4 GB can handle 1,000 threads? That is going to be part of our benchmarking discussion that we will do it later. You will get to know, your question will be answered when we get into there. Now, if I'm going to explain, it will be too much theoretical one. So after all those 3 sessions, you will get this answer, Manisha. Okay, fine, guys. If okay, one more question. Yeah, fine then. I think if there are no more questions, we can wind up today's session, and we will meet on, today is what, Friday. We'll meet on Monday. So which means I will definitely share the Google Sheet, so that you can set up your laptop with Java, with Tomcat, with Eclipse, with few other tools that is there in the list. Okay, but at least Java, and Tomcat alone. You install it over the weekend. Okay. It's just a very straightforward only. It doesn't going to take more time. So that from Monday, when we are going to learn about the various engineering topics, you would be able to do it and so on. Okay. Fine, guys. So I'll send you the once I provide the access, I'll confirm you through the WhatsApp. We will meet on Monday then. Yeah. Thank you, guys. Thanks for your time.
Thank you.
Thank you.